Okay, so let us now next prove this sixth one. Let's start with the given expression. We have to show that this is equal to tan 6x. Because of lack of space, too much space, I had to write the ratio like this. I mean, you do understand that here we have this expression divided by this expression. And that's how we are going to solve it as well. We have, so let's write the expression first. Sin 7x plus sin 5x plus sin 9x plus sin 3x. So that's the numerator divided by the same angles, but they are cosine in the denominator. Cos 7x plus cos 5x plus cos 9x plus cos 3x. Alright, so you can clearly see that we have to use the sin c plus sin d and cos c plus cos d formulas. So let's recall the formulas first. Let us also recall the scheme that we developed for remembering these formulas. When we have sine, then we have mixed terms, sine as well as cos. And when there is a plus, sine comes first followed by cos. So this one is 2 sine c plus d over 2 times cos c minus d over 2. However, when you have cos, then only cos terms appear provided you have a plus sign in between the two terms. But if you have a minus sign, both the terms are sine. That's not the case here. Here we have plus. So 2 cos c plus d over 2 times cos c minus d over 2. Okay, so that's these are the two things we have to apply here. Alright. So now that we have seen the formulas, I can erase this part. So first we have sin 7x plus sin 5x. So that will become sin 7x plus 5x divided by 2 times cos 7x minus 5x over 2, and then 9x and 3x. So 2 sin 9x plus 3x over 2 times cos 9x minus 3x over 2. So that is our numerator. And then the denominator. In the denominator we have cos c plus cos d. So both terms will be cos. 2 cos 7x plus 5x over 2 times this plus 9x plus 3x over 2 times 9x minus 3x over 2. Alright, so if we now simplify the angles, 7 plus 5 is 12. 12 divided by 2 is 6. So this will be 2 sine 6x. 7 minus 5 is 2, 2 divided by 2 is x cos x, plus 9 minus 3 is again 12, 12 divided by 2 is 6, and 9 minus 3 is 6, 6 divided by 2 is 3x. So that is our numerator, divided by, we no longer have to again do it because the angles are same in the denominator. The only thing is that the terms, the trigonometric functions are all cos. So now we have 2 cos 6x cos x plus 2 cos 6x cos 3x. Now we have reduced the entire thing to a state where we can use this format. So now you can see that from these two terms in the numerator we can take 2 sine 6x outside because it's there in both the terms, and that leaves us with cos x plus cos 3x. Similarly, in the denominator you can take 2 cos 6x outside, and the rest is cos x plus cos 3x. Now you can cancel this thing, and you have sin 6x divided by cos 6x. So that is tan 6x. Those of you who are really careful about everything, you may question what guarantees that this cos x plus cos 3x is non-zero, so that we can cancel. 2 also we have cancelled, but we know that 2 is not equal to 0. Do we know that this is also not equal to 0? Actually we know. How? You see, in the original expression we had what in the denominator? Cos 7x plus cos 5x plus cos 9x plus cos 3x. Since it is appearing in the denominator, it means that it is supposed to be non-zero. So only those values of x are being considered, although it's not explicitly stated, but they are being considered for which this is non-zero. Now before we did this cancellation up to this stage, this is what the new denominator finally has become. So this is equal to the original denominator that we have in the beginning expression. Since that is non-zero, this is also non-zero. So all its parts are also not equal to 0. In particular, this is not 0. And that gives us the liberty to cancel. And that's how we have our identity. Next we have another one, 7. Here also we have to prove something. So we have to prove this. Sin 3x plus sin 2x minus sin x. We have to prove that this is equal to 4 sin x cos x over 2 times cos 3x over 2. Okay, that's somewhat asymmetry. You have sin x here, but the other two terms are cos. Okay, we will see. So we start with the left hand side. Sin 3x plus sin 2x minus sin x. Alright, so here we are going to use two different types of identity. What we first do is, let me write the things on this side. I am going to use the half angle formula for sine. That is, this is what I am going to use. In place of sine theta, I can write 2 sine theta over 2 cos theta over 2, and that I am going to write here. Besides that, I am going to also use on these two terms the sin c minus sin d formula. Again, let's recall our scheme. We know that when we have sine, mixed terms appear, sine as well as cos. Now, because there is a minus sign in between, cos gets the preference. So, cos comes first, followed by sine. That is, this is 2 cos c plus d over 2 times sin c minus d over 2. And when we say that one function comes first followed by another, the order is determined by these angles. Always you have c plus d over 2 first, then c minus d over 2. Okay. So if we now apply these things here, the first sin 3x term will become this. Okay. Then plus 2 cos, what are the angles? 2x and x, divided by 2 times sine 2x minus x divided by 2. Okay, so let's now simplify the angles. Plus so here we are getting 3x, so 3x divided by 2. 2 cos 3x divided by 2, and 2x minus x is x, so sine x divided by 2. So you can see that we have a common 2 cos 3x over 2 in both the terms, so that we can take outside. And that leaves, so what else is there in the first term? Sin 3x over 2. Plus sin x over 2. Now here you have to again apply the sin c plus sin d formula. Again, sin is there, so mixed terms will come, and because there is a plus in between, so sin gets the preference. It will come first, followed by cos. You can already see that you are getting cos 3x over 2, which you need in the final expression. We do, however, need 4, but we have 2. But you can understand that when we apply the sin c plus sin d formula, another 2 will come. Okay, so this will be 2 sin, let me write like this, because the angles themselves are in ratio form. In other words, we have 3x over 2 plus x over 2 divided by 2 times this. Okay, so 2 times 2 is 4 cos 3x over 2. So now it's quite easy. 3x plus x is 4x. 4x divided by 2 is 2x. And that 2x divided by this other 2 gives you x. And that's why you get sin x. So you are getting that sin x. And here there is another cos term. So 3x minus x is 2x. 2x divided by 2 is x. So that means here you are getting x divided by 2. If you want, you can write one more line where you rearrange these terms according to how it's needed. Okay, so 4 sin x cos x over 2 times cos 3x over 2. And finally, we again have some 3 problems where we have to calculate some values of trigonometric functions. Find sin x over 2, cos x over 2 and tan x over 2 in each of the following. Number 8. It is given that tan x is minus 4 over 3 and x in where x is in quadrant 2, x is in the second quadrant. Note that tan x is given, not x over 2. So we need to calculate these values. Let us first see what this being in the second quadrant means. Since, we know what it means, but let's see what its consequence is. Since x is in quadrant 2, we have, so quadrant 2 means what? Between 90 degree and 180 degree, or between pi over 2 radian and pi radian. Oh, we should not think in terms of degree unless it is explicitly stated that the angle is being measured in degrees. You have to assume, if nothing is mentioned, x is simply x, you have to assume that it's in radian. And that is why we write like this. Being in second quadrant means having these inequalities. But then, what can you say about x divided by 2? So for that you divide the inequality, throughout by 2. So this clearly shows that x divided by 2 has to lie in the first quadrant. This is in quadrant 1, which immediately tells us that all these 3 values will be positive, because in the first quadrant all trigonometric function values are positive. Okay, so now we have to work with this value tan x equal to minus 4 over 3, and here we are going to use the half angle formula for tan theta. That means we will use this formula. Tan theta equals 2 tan theta divided by 2 divided by 1 minus tan square theta divided by 2. Do you see where it is coming from? It is coming from tan 2 theta formula only. That's because you can write in place of theta 2 times theta over 2. So then you just apply your usual tan 2 theta formula. So that's how you get this. Now, should I write it in this format or just simply? I think it will look good like this. Minus 4 divided by 3. So this is 2 tan x divided by 2 divided by 1 minus tan square x over 2 . Okay, so what we now do, we multiply, we do cross multiplication. Okay, that's what we do. So this side becomes 6 tan x divided by 2 and that side becomes, after multiplying this by minus 4, you get 4 tan square x over 2 minus 4. So we can divide throughout by 2. That will simplify the equation a little bit. Minus 2. So we are getting 2 tan square x over 2 minus 3 tan x over 2 minus 2 equal to 0. So this is a quadratic equation in tan x divided by 2. We can do factorization. Now if you factorize, I am not going to waste time on this. I will just simply write what we finally find. Plus 1 times this is equal to 0. You already know how to factorize this type of expressions. If you find it a little confusing, you can in fact name this something. You can call it y, then this equation will become 2y square minus 3y minus 2 equal to 0. And then you can factorize it in the usual way. You will see that you get this. Do we really get this? Let's just see. 2 times this is 2 tan square x over 2. 2 times minus 2 is minus 4 times this tan plus 1 times this, that means minus 4 plus 1 is minus 3 and plus 1 times minus 2 is minus 2, yes. Okay. Now what did we uncover here? Here we revealed the fact that x divided by 2 is in the first quadrant and so its tan value is going to be positive, okay, not negative. Since is in quadrant 1. So this is positive. So if this is positive, is it possible for 2 times this plus 1 to be 0? No. This can only be 0 when tan x over 2 is minus 1 divided by 2, which is not possible because this is positive. Hence, this is not equal to 0. So we can cancel it from both sides of this equation. However, there is a break in this chain of equivalent statements. So again you have to write thus. If and only if. No need to write everything again. If and only if this, which means that this is 2. So we have already found tan x divided by 2. So one of the values we have found. Now we have to find the sine and cos. Okay, so now what you can write? To get to cos from tan, the link is through secant, because secant square x divided by 2 is 1 plus tan square x divided by 2. So this implies so 1 plus 2 square is 5. If you are wondering why I brought double implication here, whereas here I am writing single implication, that is implies symbol, that's because here we were solving an equation. Okay, we wanted to know precisely what the values of tan x over 2 are. Here, however, we have a value, and then we want to know what happens to secant x over 2 and actually ultimately to cos x over 2. So here we are not trying to find precisely some values, okay, from a given condition. To put things simply, when you solve an equation and find the values, then you use double implication. Why do we do this actually? The reason is that, see, I started with this equation. What does it actually mean? It means that I have assumed x to be a real number for which tan x is equal to minus 4 over 3. That is my starting point, that is the assumption. If that is true, what should be x? Say you find some value of x. Actually we are not finding x here, but we are finding tan x over 2, more or less the same thing. So you find what this value should be. But is the converse also true? If you go back and put this value here, will this equation be true? Yes, it will be true. Well, not always, but the things we are dealing with, in most of them, that is the case. And that is why we can write double implication, because we can go back. And in fact, that is why when you cancel something from both sides, you have to be so careful to make sure that it is non-zero. Do you know why that is necessary? If you are going, say you start to go back from this equation, you have this equation, there is no problem. You can subtract 2 from both sides. You have minus 2 here, you have 0 on that side. And then you can multiply both sides of this equation by this. That you can do even when this is 0. But when you want to come back from that to this step, you have to cancel this. That requires this being non-zero. So that is why when you write double implication, you actually have to be very careful that you can really go back and forth as you wish. We don't need that here. Here we have tan x over 2 value. We just want to know what secant x over 2 will be. So this is 5. This implies cos square x over 2 is 1 divided by 5. Again, let us recall that since x over 2 is in the first quadrant, so all trigonometric values are positive. And that's why when we take square root, there's no need to write plus or minus, it is plus. Okay, so besides tan x over 2, we have also found cos x over 2. So now it's a simple matter to find sin x over 2. Will you use the formula for, between the relation between sin and cos here? You can if you want, but that will again involve taking square root. Instead, a better way is this. Recall the link among sine, cos and tan. What is, let me just simply denote them by S, C and T. Tan is equal to sine divided by cos, right? We have tan, we have cos, so what is sine? Sine simply should be cos times tan. That's it, you just have to multiply these two values. So cos x over 2 is 1 over root 5 and that is 2. So this is 2 over root 5. I think in the book, their answers are available at the end of the book, right? There, this value is wrongly given as 1 divided by 2. It should actually be 2. What can I say? I mean, that's the quality of NCERT books. These books contain all kinds of errors as much as possible, and most likely no one ever proofreads these books before publishing. Next, there is another one similar. In this case, cos x is minus 1 over 3 and x in quadrant 3. Alright, this is going to be quite easy. But before you do anything, no, you have to again see in which quadrant x divided by 2 will lie. Since x is in quadrant 3 means it will be greater than pi and less than 3 pi divided by 2. So, dividing throughout by 2, we will get, and note that this is less than pi. So that means x over 2 lies between pi over 2 and pi. That is the second quadrant. That is, x over 2 is in quadrant 2. So in the second quadrant, sine is positive but cos is negative. So tan is also negative. Alright, so now we are given cos x is minus 1 over 3. So this time we will use the half angle formula for cosine, which has cosine again. That means cos, in place of cos x we can write 2 cos square x divided by 2 minus 1, that formula. So this is 2 over 3. After cancelling 2 from both sides, we get this. In general, if you simply have this now, without any information on what x is or where it lies, you will have to write plus or minus. But because we now have this information that it's in quadrant 2, so cosine is minus 1 divided by square root of 3. If you want here, you can again mention that since x over 2 is in quadrant 2 for exam purpose. Okay, so we have found cos x over 2. Next, let us find sin x over 2. Sin x over 2, however, will be positive because we are in quadrant 2. And this time we can just simply use the relation between sin and cos. Oh, actually, ideally you should write here cos x over 2 is less than 0 since x over 2 is in quadrant 2. I mean, we did not specifically write anything for cos, we just wrote that the angle is in quadrant 2. But I leave those small matters to you. 1 minus cos square x over 2. So if you now square this, minus will vanish, square root will be also gone. So we get this, or 2 divided by 3, and this implies sin x over 2 is square root of 2 divided by square root of 3. Again, sign will be positive, that's why we do not have a minus here. Thus, to now find tan, you just divide sin by cos. So sin x over 2 is this, square root of 2 divided by square root of 3, and cos x over 2, do not forget the minus sign, okay, minus 1 over root 3. This type of ratios may look confusing, that's why it's a good idea to use brackets. After cancellation, you get minus square root of 2. And there is one more, that this is the last one. Here, sin x is 1 divided by 4, and x in quadrant 2, x is in the second quadrant. If x is in the second quadrant, then it's very easy for us. X divided by 2 will be in first quadrant, and so everything will be positive. Since x is in quadrant 2, so quadrant 2 means what? These are the inequalities x satisfies. Hence, i.e. x over 2 is in quadrant 1. So everything is positive. Okay, now what shall we do? How shall we proceed? Let us first calculate cos x. It's just the way things are, okay. Directly from this it becomes a little difficult to find the values. So let's first find cos x. Note that when we are going to find cos x, and we will use the relation between sine and cos, our usual thing, that cos square x is 1 minus sine square x. We will then have to take square root. Which sign will come then? X is in quadrant 2, so cosine will be negative. I can actually write directly like this. So you have to square this, that means 1 over 16 minus square root of 15 divided by 4. Alright. So now what we do, we apply the half angle formula to cos x. So in place of cos x, we are going to write 2 cos square x over 2 minus 1, usual stuff. Hence, minus 1 is equal to, this value is a little unconventional. It is a value, it's a legitimate value, but we do not usually get this type of values. One minus, the value is very interesting though, you will see why now. So cos square x over 2 is 8, and on this, in the numerator we have this. Okay, so you can just simply take square root on both sides, and that's it. That will give you the cos x over 2 value with the understanding that the value is positive. So you have to take the positive square root. But I want to show you something which happens here. Although you have somewhat complicated expression here, 4 minus root 15, but if you look carefully, you can do a trick here. You can multiply and divide by 2. That will give you 8 minus 2 root 15 divided by 16. Now we can actually write 8 minus 2 root 15 as a perfect square. That's the great thing here. How? If you look carefully, you will notice this. Minus 2 times square root of 5 times square root of 3. After cancelling the square roots and squares, you get 5 and 3. That is 8 minus 2 times root 5 times root 3. So that is your usual a minus b whole square formula. That means, in spite of having roots, radicals, everything seems to have fallen in place. So now if you take square root with the information that cos x over 2 will be positive, then you get this somewhat nice value of cos x over 2. Instead of having a square root of an expression which itself has square root, you get this. Okay, so that is your cos x over 2. So that's only one value we have found so far. So next let's go for sin x over 2. Sin square x over 2 is 1 minus cos square x over 2. So this will be 16 minus. So if I really expand and write everything, keeping this minus sign in mind, I will then have minus 5 minus 3, but plus, because if you expand this, the term having 2 will be a minus term. Minus times minus is plus. 2 root 15 divided by 16. So what shall we get here? You see that this is minus 8. So you get 8. But this time there is a plus. There you had 8 plus 2 root 15. 8 minus 2 root 15. Here you have plus. So I am just directly going to write this. And this implies that sin x over 2, that also comes in a nice form. So this is root 5 plus square root of 3 divided by 4. So we now have cos and sin, so we can write tan. Hence tan x over 2 is sine divided by cos, and that will be, I mean, if you use these values and cancel the force, you have this. If you want, you can keep it like this, or you do a little more and rationalize the denominator. So what you do to rationalize the denominator, you multiply and divide by the I forgot its name. Is it called rational conjugate? Something it is called. That conjugate word is there, which is just you replace this by the other expression which has plus here. That means this one. Now if you expand the numerator, you are again going to get 8 plus 2 times square root of 15, whereas the denominator is 5 minus 3, which is 2. And after you divide the numerator by 2, you get 4 plus square root of 15. Okay, so that is your tan x over 2. And this concludes trigonometry. So next Wednesday we can start complex numbers, and tomorrow is Thursday. Oh, so tomorrow again we have Atiyah and McDonald's commutative algebra. Yeah, I am eager to see what else this book has. What else means I have actually I already read a part of this book before, but I did not really go that far. Especially the modules part, I haven't really seen anything about that, what the book has. So we will see what we have tomorrow. So that's just it for tonight. See you tomorrow. Until then, this is me, Lucifer from A Mathematical Room. Have a nice night.